In most languages, every value can be copied, thrown away, or stashed in memory at will. That freedom is lethal when the value represents real money. Move solves the problem with abilities. 4 opt-in permissions attached to each struct. The compiler reads those tags and blocks any operation the type didn't authorize. No reflection, no dynamic flags, just static safety. Tokens forbid copying and dropping, configs welcome them, singleton objects need global identity. Once you internalize how each ability behaves, modeling new assets becomes a checklist exercise. Which operations should reality allow? Tick only those boxes. Let the compiler police everything else. The first ability, copy, says, "It's perfectly safe to duplicate me." The compiler now lets you assign the same value to multiple variables or return it twice. Use it for configs, cached computations, or structs that merely describe information. Anything where cloning doesn't mint new economic value. You'll never see copy on a token or NFT because uniqueness underpins their price. In fact, the type system forbids pairing copy with key. A globally addressable object that can also duplicate would shred scarcity in seconds. Reach for copy only when duplication truly carries zero risk. Drop grants the opposite permission. You may discard me silently when I'm no longer referenced. Languages like Java do this for everything. Move makes you choose. Temporary structs that help compute a fee or optional debug logs. Love drop. They disappear without ceremony. Resources deliberately lack this ability, forcing you to destroy them only through explicit code paths. That single constraint erases a scary failure mode where a contract misroutes tokens to a null address and no one notices until it's too late. If copy and drop answer how a value travels, store answers where it lives. Without this ability, a struct can exist only as a local variable. Try to embed it in another struct or publish it on chain, and the compiler smacks you down. Consequently, nearly every serious type lists store. It also shows up in generic constraints, struct box, ensuring the contents are storable before the compiler ever monomorphizes templates. The crown jewel is key. Add it and the runtime attaches a universally unique identifier to every instance. Suddenly, your struct can jump wallets, appear in explorers, and receive history queries. Tokens, NFTs, singleton governance records, all rely on key. Because uniqueness is sacred, the compiler forbids mixing key with copy. Technically, you could pair key with drop, but deleting globally visible assets silently is almost always a design smell. Remember, with great key comes great responsibility for explicit lifecycle management. Most designs fall into 4 reusable patterns. Valuable assets need key and store, nothing more. Simple data enjoys duplication and auto cleanup, so grant copy plus drop plus store. Internal blobs that should never wander outside their parent struct live happily with store alone. Temporary calculations thrive with only drop. The compiler won't gripe if you forget to move them anywhere. Whenever you model a new concept, ask, should copies be safe? Is silent deletion okay? Does this need a UID? Affix only the abilities that answer yes, and the type system will guard the rest. This mini module showcases every pattern in one file. Supal point matches our token. Key, store, and nothing else. Profile is benign metadata, free to duplicate or garbage collect. Config is an internal blob. We'll embed it inside a settings object later, so store suffices. Temp result exists only during a calculation. Drop lets the VM reclaim it automatically. At the bottom, we intentionally write illegal clone. Returning the same supal point twice requires a hidden copy, and the compiler refuses because the type lacks the copy ability. Comment that line out, rebuild, and the error disappears, proving the ability gate is doing its job.